Assalamu alaikum and hello everyone. Welcome to Mathematics with Shahab Yaqub. So now in this particular video, we will be solving this particular paper, which is paper 5, popularly known as S1. This is from the May-June 2025 series, and yes, it's the second variant. So now let's understand in totality how you can score your A or A star in AS A-level maths, whether you are giving the exam in November 2025 or May-June 2026. And technically it's October-November 2025. So let's look at the first question. It's worth 3 marks. It's a probability distribution classic question. It says Rachel has 3 coins, and let me underline it. The first coin is biased. The probability of obtaining a hit is 1/3, so I have written it over here. I have labeled the first coin as A. Similarly, the second coin is also biased. The probability of obtaining a hit is 1/4, that is the second one. And the third coin is fair. The probability is half and half. So head, it's half, tail, it's half. Now the very first thing after reading the first paragraph is that I have written down, I have jotted down the main details over here. Now I'll read the question further. Rachel throws the 3 coins at the same time. The random variable x is the number of tails obtained. Draw up the probability distribution table for x for 3 marks. Now x is the number of tails. The very easy thing is that probability x is equals to 0. That means no tails. All 3 are heads. So take this, take this, take this, multiply it out. Do not reduce the fraction because it's easier to add this way, 1 into 1 into 1. That is 1/24. Now from here, I'll go to the next easy one. That is probability x is equals to 3. 3 tails. So that is this thing, 2/3 into 3/4 into 1/2. That comes out to be 6/24. Now what I can do is that I can either evaluate this one or I can evaluate this one because my focus is to form this table. So if I have this probability, let's say if I evaluate this one, then this can be obtained by subtraction or vice versa. So let's say probability x is equals to 2. That means x is the number of tails, tail, tail, head, tail, head, tail. So therefore over here, tail, head, head. That is this one. And then head, tail, head, tail, head. And the third one, that is head, tail. So this is head, this is head, this is tail. It's written over here. We get this answer. My bad, it's right over here. And then similarly, this can be obtained. Write everything down. No need to reduce it. Question number 1 is done and dusted for 3 marks. Question number 2. Now it says in Milford, 70% of the residents own a bicycle. A random sample of 160 is selected. Use a suitable approximation. Find the probability more than 120 of these residents own a bike. Now let me draw a number line over here and I'll use it a bit later. Now, first of all, you need to understand that this question is about, that's a thick marker. This question is about binomial becoming normal. What do we call it? We call it normal approximation to binomial. And also let me label this one. The first question was about probability distribution. No wonder the whole paper is labeled as what? Probability and statistics 1. So there is a lot of probability in this thing. Coming back to this, so 70% is your probability of success. Our number of trials, n, is 160. Therefore, probability of failure is 0.3. Now do these calculations. Calculate NP, calculate NQ, calculate NPQ. NP is 112, NQ is 48, NPQ is 33.6. First of all, justify whether they have asked it or not. Make a habit of justifying it. It's a good thing. Make sure that you win the heart and mind of the examiner. So now since NP is greater than 5, NQ is greater than 5, therefore X follows a normal distribution. Mean is NP, that goes over here, and variance is NPQ, that goes over here. Do not, I repeat, do not confuse NQ and NPQ. Then the next thing, probability x is greater than 120. More than 120 does not include 120. So let me write over here 120. Let me write over here the upper class boundary 120.5, and this one is 119.5, and that was one noisy thunderstorm. So now let me write over here, therefore I can either choose this one or I can choose this one. Now, since 120 is not inclusive, which one should I choose? So therefore I chose 120.5 over here. So then we standardize as usual. What do? Subtract the mean, divide by variance. The square root of variance is standard deviation. So basically, let me write it over here. Z is x minus mu over sigma. Sigma square is variance and sigma is standard deviation. We get this z value. We apply the relevant rule, z greater than 1.466 and 1 minus probability z lesser than this. This is the value from the table. Let me write it over here. So this is the table value, and write the 4 decimal place value. The final answer automatically came out to be 3 significant figure. Now the first piece of advice is that take care of exact form where necessary. Take care of accuracy where necessary. We are solving an S1 paper. So therefore the rule is work in for SF. Therefore final answer should be in 3SF. That is the rule that you have to follow. And naturally, the third most important rule is that show all necessary steps. Everything that I'm doing over here. And that is how I teach my students. That's how they score these A's and A stars. That is, show all necessary steps and follow the instructions that I give. And some people are studying live from me on campus, and some people they study from me through these lectures. Let's go to the third one. What is the third one? The third one is a bag contains 4 blue and 12 red marbles. I think this looks like a conditional probability question. This looks like a tree diagram question. Whether they ask us to draw it or not, that is our personal choice. Now it says a bag contains 4 blue marbles, 12 red marbles. 1 marble is selected at random from the bag. Now here are the rules. The rules of the game are, if this marble is blue, that means if you select a blue, let me choose a black marker over here. So this is the first draw. If we select a blue, it is replaced. That means the denominator does not change. So 4 plus 12 is how much? 16. This is 16. This is 16. So in this first branching, for the second draw in front of blue, this 16 is unchanged. But what is the next rule? But if it is red, if we select a red in the first draw, it's not replaced. That means this is without replacement. So 16 becomes 15 over here. So that was a nice question. A second marble is now selected at random from the bag. So now these are all the possibilities. This is called possible outcomes. So in terms of color, I have written BB. I have written RR. Let me also write a B over here, a B over here. Let me write an R over here, an R over here. So there are 4 possible options. That means blue, 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 red, and red, blue, and red, red. All good, all clear. Now the first part, find the probability both marbles selected are of the same color. So it could be blue, blue, that is the option 4 over 16 into 4 over 16. So let me write over here, that is 4 over 16 into 4 over 16. That is the probability that I'm writing over here. So let me adjust this thing, this outcome word, it looks better over here. And over here, let me write the word probability. All good, all clear. And the second option is that of red, red. So that is 12 over 16 into 11 over 50. So over here, this is red, red. So this one over here, that is red, red. And this one over here, that is blue, blue. And take care of the fractions. Of course, everyone has studied either O-level maths or IGCSE maths, multiplication, division, addition, subtraction, all these things should be there. So put it in the calculator, you get this thing, and this, if someone is interested in decimals, this is exact, no need to round off. Exact, no rounding off. Find the probability first marble is blue given that second marble is red. So when the word given comes, that means it's a conditional probability question. And what comes after given, that is the condition. Given that the second marble is red, that means the second marble is red. So let me highlight it. The second marble is red. The first could be red or the first could be blue. This was already evaluated earlier on. That is red, red. That is right over here. This one is basically this one. And blue, red. So blue, red is this one. Let me write it over here. That is 4 over 16 into 12 over 16. That is blue, red. That is over here. And we add this thing. That is 59 over 80. The condition goes down in the denominator. Now read the question once again. Find the probability first is blue given that second is red. First is blue given second is red. This thing is the numerator. Divide. This is the exact answer. This is rounded off correct to 3 significant figures. So 3 questions are done and dusted. Let's go to the fourth one. So now in the fourth question, and it's a very classic question, but I'm a bit shocked. They only used one part for that classic question. They could have changed it into other parts also, but they prefer to use geometric and maybe binomial later on. Vehicles approaching a certain road junction from a particular point, let's say B, Bromley, must go either left or right or straight on. So technically it's like this. So the car is approaching and it's either left or it's right or it's straight on. So that is how things are going. And this is that particular town or city, that is Bromley. So this is left, this is right, this is straight on. That is how the options are. And the corresponding probabilities are given, they are fixed. The driver of each vehicle chooses a direction independently. Find the probability of the next 3 vehicles, all go in different direction. So they can go left, or they can go right, or they can go straight on, but in different orders in 6 different possible ways. How do I know that? Because this 6 is basically left, right and straight, left, straight and right. It could be right, left, straight, right, straight, left. It could also be straight, left, right, straight, right, left. So these are 6 options. Technically, this is 3 factorial, which is 6. So you multiply it out, you get this answer. Again, it's exact, no need to round off. Be very, very clear about the rubric that is mentioned at the beginning of the paper. So rubric is, that is the set of rules that we need to follow in the paper, and that is what we are following. Now the next one, it says find the probability that from the vehicles approaching the junction from Bromley, the first vehicle to go left is before the 9th vehicle. Before. This is geometric probability distribution. Probability of success is 0.3 because that is for the left. Probability x less than 9. It could be 8, 7, 6, 5, 4, 3, 2, 1. So the shortcut is this one, which you have studied in class. So let me write it over here. Probability x is lesser than n. That is probability, or let me write it like this. Probability x is lesser than or equal to n. That is 1 minus probability of failure raised to power of n. A very, very important rule. So since 9 was not included, therefore I wrote x is lesser than or equal to 8. 1 minus probability of failure raised to power of 8. Unrounded value, rounded value, show all these steps. Now this question is very, very common in 2024 past papers, and that is a mix of binomial and geometric. Find the probability from the vehicles approaching the junction from Bromley today. The second vehicle to go left is the 7th. That means the 7th vehicle definitely will be going left. So keep it aside. And out of the first 6 cars, one of them would be going left because this is the second one to go left. So keep it on the side. And this one is like a fixed probability, that is geometric, keep it fixed. And over here, it could be the first position, second, third, fourth, fifth, sixth. It could be one of the six. Therefore, it's binomial. So 6C1, success raised to power of 1, failure raised to power of 5. 6C1 is 6. This is as it is, 0.3 into 0.3, that's 0.3 square. That is how it's written in the mark scheme. I have explained it over here. 4SF, 3SF, that is the final answer. So also make a habit of underlining it. So over here, this is the final answer. Over here, this is the final answer. Over here, this exact is the final answer. Over here, I'm writing in fractions. Over here, where it is? Over here, there is the final answer. Similarly, this is the final answer over here. Similarly, these 4 in the table, that is the final answer. So make a habit of underlining it. I have used a highlighter, which of course you cannot use in the exam. Now over here, question number 5, comparatively the boring part because you have studied it in O-levels also. The time taken by 300 students to travel from H college is recorded, the results are summarized. So this is a cumulative frequency table. T is less than or equal to 10, less than or equal to 20, and so on. On the grid, draw a CF curve. Now the very first thing that I do over here is that I count the squares. The cumulative frequency, it goes on the y-axis. It goes till 300. So always choose a comfortable scale. If I choose this to be 50, 50, 100, 150, 200, 250, 300, if this much is left, no issue. Similarly, over here, the maximum value is 90. So I chose 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I just wrote 100, but technically we are going till 90. I was just checking my working. So basically we are going till 90. So now on the horizontal scale, we have the upper class boundary. And on the vertical axis, this is x-axis, the horizontal axis, cumulative frequency goes on the y-axis. And I think it's a good idea to write down the scale. So over here, one small square, x-axis, one small square is like how much? That is like 2 units. And on the y-axis, one small square is like 5 units. Make sense? Double check. So over here, this is like 10. And this is 2, 4, 6, 8, 10. So this is 2 units. Over here, this is 5. Double check. So now let me go back over here. Now this thing is drawn. It says cumulative frequency graph. I have joined it using freehand. Someone can join it using short line segments also. Now 120 students take more than k minutes to travel to college. Use your graph. Now keep in mind, cumulative frequency is based upon the keyword, key phrase less than, lesser than this, lesser than this, as you can see it over here. Got the idea? So if 120 travel in more than k minutes, therefore 300 minus 120, 180 travel in less than k minutes. So go till 120 cumulative frequency, touch the graph, read off the value. Now keep in mind, this I have drawn it on iPad. You will be drawing it with pencil and on paper, so yours will be more accurate. So my answer is coming out to be between 33 and 34 minutes. I have written 33.5. In the mark scheme, it's written as 35 minutes. So of course, there would be slight error. Of course, the examiner takes into consideration the human error that is taken into consideration. So now the next one, calculate estimates of mean and standard deviation. So what I've done is that I've pasted that table over here. Of course, you cannot do that. You have to copy the result. Now the next thing is that lesser than or equal to 10 means the time cannot be negative. So 0 to 10, there are 34 people. Now 10 till 20, subtract these two and write it over here, 52. 20 till 30, 142 minus 86, that is 56. Between 30 and 40, 208 minus 142, that is 66. Between 40 and 60, 265 minus 208, that is 57. Between 60 and 90, 300 minus 265, that is 35. So basically what I have created is a frequency distribution table, and I also now need the mid value of these class intervals. So that's 5, 15, 25, 35, 50, and 75. I'm working with 6 pieces of data, the purple and the green. Keep that in mind. All good? So now X bar is sigma fx over sigma f. So now let me choose, let me just increase the brightness, that is too bright, and let me choose this thing. So this is the purple value, that is 5, 15, 25, 35, 50, and 75. And the corresponding frequency is in green color, 34, 52, 56, 66, 57, 35 correspondingly. And let me also write it over here just the same way. And the purple thing is like this 5 and square, and this 15 square, 25 square. I'll just go over the formula and so on like this. So now the formula for X bar, that is sigma fx over f. So this is f into x. Got the idea? The whole thing divided by sigma f. Sigma f is 300 students. Okay, got the idea? So we get this exact answer. This is the 5 SF answer. This is 3 SF for this part. The formula for standard deviation square, I'll take the square root at the very end. So I don't like writing a square root everywhere. So I just write variance, sigma fx square, that is x square, that is f, that is x square, that is f, minus x bar square. So I use this value over here. So let me highlight this orange value, this thing over here. I have written it over here, squared. That is this thing. I think the steps are all good, all clear, and the standard deviation is coming out to be this. So standard deviation is 20.4 and the mean is 33.8. So therefore, let me write over here, X bar, that is 33.8, standard deviation, that is 20.4. Both answers are given correct to 3SF. Take care of the accuracy. Don't lose any marks for that. Now we are on question number 6. It says find the number of different ways in which 10 letters of the word amalgamate. So A, M, A, L, G, A, T, E, and I think I missed A, M, A, L, G, A, M, A, T, E. Okay, all good, all clear. So there are 4 A's, 2 M's, 1 L, G, T, E. So there is an M at the beginning. M is fixed, identical, one option. M is fixed at the end, one option. And then the no A's are together. That means they all are separated. So A's are all separated. That means the space concept. So we have L, G, T, E, and there are 5 spaces over here. Out of these 5 spaces, I'll fit in 4. I'll fit in 4 A's. But since the A's are identical, so this is identical A's. So therefore, that is why divide by 4 factorial. And this green 4 factorial is technically for LGTE, and that's the way that it can be arranged. Final answer is 120. Of course, use a calculator. The next one, find the number of different ways in which 10 letters can be arranged with exactly 3 letters between the 2 M's. So this one, you have to write it out. So there is a M in the first option, you can say, the first position. Then 1, 2, 3 blank, then the 5th position, and then 1, 2, 3, 4, 5. So it doesn't make a difference where the A's are, where LGTE is, doesn't make a difference. So 1st and 5th, and then 2nd and 6th, and then 3rd and 7th, and then 4th and 8th, and then 5th and 9th, and then 6th and 10th. So there are 6 possible lines. 6 possible lines means rows. 6 possible rows are there. And then what about these 8 letters? They can arrange them in 8 factorial ways. But why divide by 4 factorial? Because of the identical A's. That is why we divide. And this is the answer that we get. Again, this is exact, no rounding off. This is exact, no rounding off. Now the third one, 5 letters are selected from 10 letters of the word amalgamate. Find the number of different selections in which 5 letters are selected, at least 1 M, at least 2 A's. So separate out the M's, separate out the A's, separate out the others. So we need 1 M, at least 1 M. At least 1 M. Let me grab my blue marker. So that is at least 1 M, and let me grab my red marker, at least 2 A's. So therefore, if I fix this is 1A, 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 it's a 1A series. So now what am I doing? I'm doing 2 A's or 3 A's or 4 A's. So that's how I'm changing it. Got the idea? Now let me focus on the rest a little bit later. And then if I have 2 M's, that means at least 1 M. So after 1 M, you can have exactly 2 M. Let me write it over here. This is exactly 1 M. This is exactly 2 M. So that will take care of what? At least 1 M. Exactly 1, exactly 2. And then based upon that, I'm changing this. Based upon that, I'm changing this. So now over here, 2 M's are there. So I can have, let me grab the red marker. I can have 2 A's and I can have 3 A's. So now look over here. When we are dealing with identical stuff and when we are dealing with selection, so when we are dealing with identical selection, whatever extra is left, discard it. 1 M is used, discard. 2 A's are used, discard the rest. So basically the decision is made by these green people. So 1 plus 2 is 3. We need 5. The rest 2 out of these 4, that's 4C2. 1 plus 3 is 4. 1 is left. 1 out of 4, 4C1. 1 plus 4 is 5. 0 out of 4, that's one option. 2 plus 2 is 4. 1 out of 5, 4C1. 2 plus 3 is 5, 0, 0 out of 4. So 4C2, 4C1, 4C0, 4C1, 4C0. This adds up to 16. That is how this thing is done. Now the last question, that is about normal distribution. Kestrels, a bird whose adult wingspans are normally distributed with this mean and standard deviation, random sample of 120 is selected. How many of these 120 would you expect? So remember that in binomial x follows a binomial distribution n comma p. There is this expected value. Expected value is np. So I'll be using this in a short while. So in the beginning, this is normal distribution. So we use normal to find probability. And then binomial jumps in over here because we need to find the expected value. So that is basically the concept of average. Nothing special about it. Now it says how many of these would have a wingspan between these two values. So write x lying between these two. Write x into z. Standardize, standardize. This is negative. This is positive. So according to the rules that I've explained in class, and I don't need to even draw a diagram. So that is rule number 7. If it lies between a positive and a negative value, what do we do? Remove the negative sign, read the table for 0.75, read the table for this thing, add the probabilities and subtract 1. This is what you get. So now there is no rounding off. So this is table based. This is table based. We add these two, subtract. This is as it is. Leave it as it is. Because they are not asking for probability, they are asking for expectation. So there are 120 of them. Multiply it with the probability, you get this answer. You can either write this as 54, you can write this as 55. It's necessary to write this thing as an integer, whether you round it up or round it down. Doesn't make a difference. So question number 7, the first part is done. The second part, the simultaneous type question. The masses of adult are normally distributed. So first of all, they were talking about what? They were talking about wingspan. This is in centimeters. Now they are talking about the masses. We are talking about kilogram. Keep that in mind. It is known that 20% of adult kestrels have a mass greater than 0.202. So let me use a red marker. 20% mass greater than 0.202. That is the information over here. The second piece of information, 28% have a mass lesser than this. 28% have a mass lesser than this. So now once this is done, what do? We convert. We convert it like this. Or this probability was lesser than 50%. Over here, this is lesser than 50%. What do? Flip the inequality, subtract the probability from 1. This is lesser than 50%. Subtract the probability from 1 and flip this thing. So now we have this thing over here. So now we are working in green and purple. So now the green thing, what does it become? The green thing, this is you change it into z. You standardize in terms of mu and sigma. We are looking for the value of mu and sigma. And then For 80% probability, we read this value from the table. Similarly, over here, we standardize over here. And for this particular probability, we read of this value. Now remember, if Z has a, let me use a red marker, if there is a lesser sign, Z value is positive, provided this probability is definitely greater than 0.5. Over here, probability greater than 0.5, there is a greater sign, Z value is negative. So take care of this. Take care of this positive sign over here. So now we compare this with this. That's equation number 1. So let me write over here, that is equation number 1. And we compare this with this, and that is equation number 2. They both are equal to sigma. Solve simultaneously. When we solve simultaneously, we show some of the working, and I have written the answer down. Mu is this thing, sigma is this thing. Again, these answers are given to 3 significant figures. And the last part of the last question, it says 10 adults are chosen at random. Find the probability fewer than 3 have masses greater than this. Now be very, very vigilant. Very, very vigilant. That is, do not do the calculation again. Be very vigilant. This thing was used earlier on. Where it is? There it is. Mass greater than 0.202, that is 20%. So that is the probability info given from part B. Now, since number of trials is given, so this is N, this is probability of success lesser than 3, does not include 3, lesser than or equal to 2. That is 10C0, success raised to power of 0, failure raised to power of 10. 10C1, probability of success raised to power of 1, probability of failure raised to power of 9. And similarly, you obtain this. Write each answer separately. So now this thing over here, this is the answer. This thing over here, this is the answer. This thing over here, this is the answer. Show all steps. And then you add it up. This is 4SF, and then the final answer is this one. That is how it's done and dusted. So now that was a 50-mark paper. Let me give you a brief overview. And I think I just pasted the P1 thing. So let me go over here. And the S1 thing is over here. So let me try pasting it over here. So now the S1 thing, and let me just show it to you over here. So now over here, for this particular paper, this is component 52. 39 out of 50, that's your A. 33 out of 50, that's your B. 26 out of 50, that's your C, and so on. And overall in this paper, when we add P1 and this thing, 100 is your threshold. So 39 out of 50, 61 out of 75, 39 plus 61, that is 100. So 100 out of 125, that is the threshold for an A. 85 over 125, that's the threshold for a B, and so on. So coming back to this. So now this particular paper, 39 out of 50, the threshold for an A, I think that's pretty good paper. I think there was nothing challenging, provided people have solved the recent past years papers such as 2024 or 2023 or 2022. I think at least these 3 years, all variants, that ensures that you have a wonderful paper. And now the results are out. Mashallah, a lot of people have messaged me and sent their scripts over and everything, and they have done wonderfully well. So now for those who are appearing in October, November 2025, make sure to follow the channel, keep the notifications on, and just go over these questions, try them out, understand in totality, and inshallah you will have an A in AS level, an A star, and A in A2, just like my other students. Take care, everyone.